VPowers, final project for Psych324, and this one is called Did You Say Something? Studying Non-Clinical Voice Hallucinations. And for this study, I chose this one, which is called Distinct Processing of Ambiguous Speech in People with Non-Clinical Auditory Verbal Hallucinations. And this was a study from 2017 that aimed to figure out why people heard voices in general, even if they didn't have a diagnosis of hearing voices with any other psychological issues. So the thing is, why do we hear voices? The short answer to this is there's something in our brains that lets us figure out what is actually speech, what is an intelligible sound, and if that sound makes sense. Is there speech coming from that, or is it really nothing? And who really pays attention to noises that much to try to hear if there is anything to it? So to explain a little bit into this, I found this clip from Dr. Tracy Marks called Is Hearing Voices Ever Normal? And so she discusses this briefly as well.
Experience of hearing a discrete sound. It just sounds like it originated from inside of your head instead of inside of the room. So that's what I mean by hearing voices, just so we're on the same page with that. There's a lot of research on this topic of non-pathological voices or non-clinical voices, and I'll put some references in the description for you. Some of these studies used functional MRI to look at brains of people who reported hearing voices. The functional MRI shows brain activation in certain parts of the brain when the person is hearing the voices. It's differences.
So that's a little bit of an introduction to the study. So with speech in mind, we have key terms. Sine wave speech, or SWS, will be mentioned throughout, as well as CVH, which stands for non-clinical voice hearers. And SWS technically is a form of acoustically degraded speech, according to the article. So some of the participants that came to this study, it was a small pool of people. We have 12 non-clinical voice hearers, or the NCVH group, and 17 non-voice hearing participants, which consisted of the control group. And all of them were over the age of 18, and none of them had a prior diagnosis related to hearing voices. And so for this experiment, the researchers used a MRI similar to the one here, a 1.5T Siemens Avanto, and they used MATLAB to record the activity that was going on, especially related to the degraded speech. And in this experiment, the researchers used a vocoder, which is a device that compresses and synthesizes human speech to sound like anything but speech. And in this case, the study took place in England, Great Britain, if you want to get technical. And they had a background voice of a man with a British accent, and they synthesized that and degraded that with a vocoder and used that in the MATLAB to give to the participants. So the participants were in the MRI and were told to press a button if they heard a target sound. And so for the target sound, the researchers didn't tell them that it was a part of speech or if it was words or a phrase. They just said to look for a noise that sounded like anything different than what other noises they were currently hearing. So during this experiment, the participants claimed to hear robotic noises or noises similar to characters from the show called The Clangers, which is a British show. So I had to look it up to see what exactly the clangers are. And I found this. So as you can see from this, these are probably noises that the participants figured sounded like speech, but really were not speech at all. But especially with the clangers, you can kind of tell that maybe your brain wants to figure out a speech from the tones that they're using, and that would be comparable to what the participants were most likely hearing while they were in the MRI and seeing how they're reacting to those noises. So, for example, some of the findings that took place here, the researchers found that between the control group and the NCVH group, the certain parts of their brain were activated to listen for this unintelligible and intelligible speech. So we can see a larger version here. So in figure A, the intelligible SWS perception, there are more areas of the brain lit. And in this case, this is taking place in I have the term, and I just want to make sure I'm saying it correctly, the bilateral frontotemporal-parietal network. So, in other words, it's part of the brain that deciphers speech. So, with the SWS perception, the sine wave speech, we see that there is a tiny bit difference between that and the unintelligible SWS perceptions, but similar areas to the brain are being activated, whether it's intelligible or unintelligible. Let's go back to this one a little bit here. With the intelligibility network and the control group versus the NCVH group, we do tell that there is a little bit more activity in that part of the brain with the NCVH group versus the control group, most likely because the NCVH group was most likely trying to hear for speech already. So the control group who didn't claim to hear voices were most likely not really looking for that. They were just going by what they were told, and the instructions in 2 different runs of this experiment is to hear for noises that didn't sound like the other ones. So what this study found was a part of the brain that was activated was called the ACC, which is the anterior cingulate cortex. So that's what was being activated spontaneously throughout the brain in both cases. But we'll see that both between the control group and the NCVH group, that similar areas were activated. There was a slight difference between them, but overall it wasn't such a huge difference that it was very noticeable at all. So a couple of the limitations from this experiment, as we saw, the sample group was very small and they needed a larger amount of people to participate in this. And not only that, they had to rely on the participants' claims of hearing speech and pushing buttons. And as far as pushing buttons, there were a few people that pushed buttons incorrectly, or their responses were not recorded accurately, so they had to do it again. So there were a few problems that came with this study. And another thing I found from the article is that it is hard for them to find enough people in these kinds of experiments, most likely because the idea of people who hear voices versus people who don't hear voices has some kind of a stigma to that. So the participant pool may not be as easy to find as for some other experiments. So, in conclusion, what the findings showed was that even though the NCVH group can hear certain distinguishable sounds in the environment, they did it sooner than the control group, but most likely because they were already trying to find speech from the different sounds in there. And we did find that even though similar areas of the brain were activated, it wasn't that big of a difference to say that between the control group and the NCVH group, that they found a huge difference. It was roughly the same for all of them. And notably, hearing noises in the NCVH group comes from a more quote unquote mundane and ordinary noise in the environment. So it goes back to the idea that our brains pick up things, noises in the environment that sound like speech or could sound like speech. And that's when those certain parts of our brain are activated to try to figure out what the speech patterns are, if there are any. So what I found from this experiment, not only realizing that we are largely flesh and bone and blood with electricity in the tops of our heads, it did also demonstrate that there may be some parts of the environment that we can explain as far as where noises come from and that could have speech related to them, but there are other parts of the world that we may not know that science just hasn't found yet. So this experiment showed that we probably do need more tests similar to this to be able to have a more conclusive opinion on this, or just not even opinion, a fact of this. So with that, I conclude this presentation, and thank you for giving me the chance to speak about this. And now I have scientific proof that we are not just hearing things. Our brains are just very interesting and smarter than we realize.